Hello, this is FlippedHarber for Algebra 2. In this video we'll talk about section 4.6, row operations and augmented matrices. An augmented matrix is basically the coefficient matrix from a system of equations with the constant matrix tacked onto the end. Now we're going to use these augmented matrices in order to solve the system of equations. The way we're going to do that is using what's referred to as the elementary row operations. Now, here they are listed in no particular order. We can switch any two rows. Now this would be like taking the top equation and the bottom equation in a system and switching them. It really doesn't do anything to the system. It really doesn't do anything to these matrices. We can multiply a row by a non-zero constant. Now again, this would be like multiplying the entire equation by the same number both on the left and right side. Again, not that big of a deal. Now here's the big rule that we're going to be able to follow in order to get rid of things. We can replace a row with the sum or difference of that row and another row. So here we see that they've taken the bottom row, 4, 5, 6, and added the top row, 1, 2, 3. Now we can also go ahead and combine any of these operations any way we want. We can do them in any sort of order. We can combine the second and third rule. So instead of just adding two rows, we go ahead and multiply one of those rows and then add them. Now these elementary row operations should only be followed with augmented matrices. Do not try to use these with just regular matrices. Only with augmented matrices. Now don't get too excited about this. This is really just solving a system by elimination, but we're using a matrix to keep everything in order. Now, our goal is what's referred to as the reduced row echelon form. You'll notice that it has the identity matrix and then the column matrix. Excuse me, the column of constant matrix. Now the top row, 1, 0, and then the 5, means that x equals 5. The bottom row, 0, 1, and then the 2, means that y equals 2. So we get it to this reduced row echelon form, and we can just read off our answer, 5, 2, for this system of equations. Alright, so let's go ahead and try this with this system of equations. Now your first task is to write the augmented matrix. You take your coefficients in order, 3, 2, and then you put a bar, and then you write the constant from the other side, 2. Our next equation is in standard form. It's got the x term first, then the y term, so 1, -4, and then on the other side of that bar is our answer, our constant from the other side, 24. Now, we're going to go through some row operations. This is not the only way to solve this. You can do these row operations in almost any order that you want. You just need to think about the goal that you have at the end. Okay, these may not be the exact same row operations you would have chosen. I might go about finding the answer in a slightly different way than you would. But either way, as long as we're both following the rules for elementary row operations, we should come to the same answer. So let's go through this one. My first change, you'll notice that only the top equation, the top row, which represents the top equation, has been changed. I doubled it. Now, I did that so that I could attack one of those 4's in the second column. Now, which one do I want to get to 0? Well, I'd like to get the 4 in the top row to go to 0. So my next operation is I will take the top row, row 1, and I will add row 2. Now you'll notice all through this I have not touched row 2. Now I just used it to change row 1, but that does not change row 2. Now that I've got 7, 0, 28 in row 1, I can go ahead and divide by the 7, and my top row is basically done. I've got 1, 0, 4, which means that x equals 4. Now I'm going to use that 1 in row 1 to get rid of the 1 in row 2. The way I do that is by subtracting. I take row 2 minus row 1. The 1's cancel. That 0 in the second column does not affect the negative 4. Negative 4 minus 0 is still negative 4. And 24 minus 4 gives me 20. Now I'm just going to divide by the negative 4 to make it a 1. And I'm now in my reduced row form, my reduced row echelon form. I've got my identity matrix in front, followed by the two constants on the other side of the bar. So now I can read off my answer is 4, comma 5. That means that x equals 4, y equals negative 5. Okay, let's try another one. 7x plus 2y plus 4 equals 0 is not in standard form. So I need to move that 4 over by subtracting it. Once it's in this standard form, then I can go ahead and make my augmented matrix. Now I'm going to try to use one row to get rid of terms in another row. Let's go ahead and multiply the top row by 3, the bottom row by 2. Now the reason I did this is to get those numbers in the second column the same. Now I'm going to use 1/6 to get rid of the other. Which 6 would I like to see go to 0? Well, I'd like to see that top 6 go to 0. So I'm going to take row 1 plus row 2. So 21 plus the 10 gives me a 31. 6 plus a negative 6, that gives me that 0 that I want. And negative 12 plus 74 gives me 62. Things are starting to work out very nicely. I divide by that 31 and I've got my top row all done. Now I need to get rid of that 10. So let's go ahead, multiply row 1 by 10. I can undo that later. It's okay to do this. And now I'm going to add row 1 to row 2. So I'm changing row 2. I'm not changing row 1. I get 0 in the front of row 2, which is what I wanted. I get a, well, that should be a positive 6, not a negative 6. Oh, excuse me, it is a negative 6. It's not, it should be a negative 6 right here. But anyway, I get negative 4 on the other, negative 54 on the other side. So now I divide by 10 on the top, I divide by negative 6 on the bottom, and I see my reduced form, and I see my two answers, 2, 9. Okay, let's try a bigger one. This is going to be our last example, and then you're going to have to try some of these. Again, make sure that everything is in standard form. Should be the x term plus or minus the y term plus or minus the z term equals a number. So I got to move the y over and I got to move the 1 over. I've got to move the y over in my second equation. Notice there's no x term. I'll show you how to deal with that in a second. Move the z term over in the bottom equation. Notice there's no y term. We'll deal with that when we make our matrix. So everything's in standard form now. So now it's time to make our augmented matrix. Now you'll notice wherever a term is missing, I've put a 0. So the top equation becomes the top row, 1, negative 1, 1, and then after the bar is my negative 1. Row 2, I have a 0 in the first column because there's no x term in the second equation. So 0, negative 1, 4, 0. My bottom equation becomes the bottom row, 2, 0, negative 1, 8. Now I'm going to go through. Now you want to try to preserve the zeros that are in the right spot. Don't worry about preserving the ones. If you have a 1 that you like, you'd much rather lose that 1 and then get it back later rather than losing those zeros. I like the 2 zeros where they're at in the front of the augmented matrix. I want to try to preserve those, and I will sacrifice 1s in order to make that happen. The zeros are more important than the 1s. So the first thing I'm going to do is actually take row 1 minus row 2. That's going to get rid of the 1 right in the middle of row 1. So 1 minus 0 is still 1. Negative 1 minus a negative 1 gives me that 0 that I want. 1 minus 4 is negative 3, and negative 1 minus 0 is negative 1 still. Row 2 and row 3 have not changed. Now, again, preserving the zeros is more important than preserving the 1. So I'm actually going to change that 1 that I like in the front of row 1, but I'll get it back later. And what I did is I used the negative 1 all the way down there at the bottom in row 3 to get rid of the 3 in row 1. I went row 1 minus 3 times row 3. Again, that's row 1 minus 3 times row 3. Now, I lost my 1 in the front of row 1. That's okay. What I gained in row 1 was that second 0 that I wanted. So looking at row 1, all I need to do is divide by a -5 and row 1 is all set. Now row 1 becomes a very powerful tool. That 1 I can use to get rid of anything in the first column. The zeros won't destroy any zeros that I already have. So my next step is going to be to go after that 2 in row 3. So I'll go row 3 minus 2 times row 1. Again, what I did here was row 3 minus 2 times row 1. It got me the 0 that I wanted in the front. I didn't lose my 0 right there in the middle. And I have -1 in that last column and a -2 on the other side of that bar. Pretty easy to go ahead and drop the negatives. I've got row 3 all set to go. Now row 3 becomes a tool in order to fix row 2. I can use that 1 to get rid of the 4, and the 0 in the front of row 3 is not going to hurt that 0 that's already in the front of row 2. So now I'll go row 2 minus 4 times row 3. Again, what I did here was I went row 2 minus 4 times row 3. All I need to do is drop the negatives. I've got my identity matrix in front, so this is in reduced form, and I can see my answers. X equals 5, Y equals 8, Z equals 2. I'll write that as an ordered triple, and I'm all done. Okay, so now it's time for you to try some of these on your own. I'll see you in class, and I'll see you online.